Um, no, I'm going to change this. What do we call this? What do we call this thing? Are you kidding me? A what? It's an equation. Yes, I heard you. Yeah, I was agreeing with you. No, I heard you. If you don't recognize this as an equation, then it's time to go back and relearn like middle school. Come on, you guys. How do I solve this? You guys should know how to solve these. Add 10 to both. So we want to get x by itself. So we add 10 to both sides. And that gives us 4x equals 8. And then divide both sides by 4. So x is equal to 2. Okay? This is what we call a linear equation. We are now going to work on ones. Like this. What's the difference? There's a square. Okay? We give those a certain name. And how we solve it depends on how the x squared equation looks. With linear equations where it's just x, no exponent with the x, okay? We always just do a series of opposite operations to get, or inverse operations to get the x by itself. Here with these ones, we do it a little bit differently. So, in the last unit, we looked at quadratic functions. Which are functions that have what we call a second degree. Second degree just means it's got an exponent of 2 in it. It's got an x squared. Okay? So those were functions. What we did is we were able to graph them. We were able to state a whole bunch of properties of them. We were able to state them in a couple of different forms, vertex form and standard form. Okay, and then we were able to solve certain types of problems with them. Well, what happens if we take an x squared and make it equal to something? Well, then we have created what is called a quadratic equation. Okay. Which we call second degree equations. Second degree equations. And how do we recognize second degree equations? We see an x squared. Okay. And they take this form. And it looks like standard form from the functions we did. Ax squared plus bx plus c, not equal to y, but equal to a number, equal to 0. That's the difference between quadratic equations and quadratic functions. So quadratic functions It's y, or f of x, we saw that function notation, equals ax squared plus bx plus c. Okay? It was y, it was never a number. But with quadratic equations, we are going to replace the y with 0. So instead of y, or f of x, it's 0 equals ax squared plus bx plus c. Or ax squared plus bx plus c equals 0. It's the same thing. I just wrote them in a different order. Very important, actually, a never equals 0. Because if it does, then it will make the x squared disappear, and it's no longer a quadratic function. So basically, you can take a quadratic function, and if you put a number here, you've created a quadratic equation. That's really the difference between the two. Okay? How we solve these things depends on how they look, like I said at the beginning. One word that you're going to see many times, instead of the word solution, so instead of the word solve, you may be asked to find what we call the roots. Don't confuse that with square root. If you're asked to find the root of an equation, that means the same as finding the solution. So solve this equation means the same thing as find the root of this equation. And with quadratic equations, there's three things, three methods. There's something that we call the square root principle. But there's many quadratic equations that we can't use the square root principle, so we have to use our knowledge of factoring that we learned in grade 10 to solve them. And there's even some that we can't solve by factoring, which means we're going to learn a certain formula that will help us solve, called the quadratic formula. And actually here, I've called it the square root property, so I should be consistent here. Principle or property means the same thing. Okay, before we talk about this one, you guys have actually done some quadratic equations before. Whenever you did Pythagoras, you always solved the quadratic equation. Because Pythagoras was always a squared plus b squared equals c squared. And as you did it, you ended up a squared equals something, b squared equals something, or c squared equals something. So you could solve this for me. If x squared is 16, what's x? 4. And that makes sense because 4 squared is 16. 4 times 4 is 16, and that's correct. But it's not the only answer. What else times itself gives you positive 16? 4 does, you're right. But there's another number times itself that gives you positive 16. No? No, you're overthinking. 4 times 4 is equal to 16. Another number, some other number times itself is also equal to 16. Think of positive and negative signs. Sorry? Negative 4 and 3? Right. Isn't negative 4 also an answer? Doesn't negative 4 times negative 4 equal to positive 16? So yes. So in this one, x would equal 4 or negative 4. Or a way that we could write it in one step is that notation, plus minus 4. So when we solve x squared, if we're given x squared is equal to some number, we can solve for x by taking the positive and negative square roots. So if x squared equals k, then x will equal the positive square root of k, and x will equal the negative of the square root of k. Be careful with that because many students miss that. They forget about it. Or, like I said, we could just do it in one shot. X equals plus or minus the square root of k. So really what we did here to solve for k is we took the positive and negative square root to cancel out the squared, which meant we took the positive and negative square root of the 16 to get positive 4 or negative 4. How about this next one? What would you have to do first, do you think? Add 17 to both sides. Get the x squared by itself. Excellent. And now, to solve for x, take the positive and negative square root of 17. Well, can you take the square root of 17 and get an exact answer? No, you get an approximate answer on your calculator. Notice that it says, I want the exact answer. So guess what? You're done. You don't have to go any further. If you remember, these are not meant to be done on their calculator. We're asked to express exact answers. How about this one? Well, x squared is by itself. How would you find x? The positive or negative square root of 45. Well, you can't do that and get an exact answer, but can it be simplified? Yes. So you've got to be able to simplify it if you can, because it breaks down to this, which simplifies to that. So if you can simplify it, do so. If there's a perfect square that goes into it. Finally, this last one. What would you do first? Yeah, divide both sides by 2 to get the x squared by itself. So we get x squared is equal to 11 over 2. Therefore, x is equal to the positive or negative square root of this fraction. Well, we can't simplify it. There's no perfect square. We can't take it exactly. So we're done. Okay. So, but notice before I stop here, notice there were only x squareds and numbers in the equation, right? What if I had something like this? Is that still a quadratic equation? Yes. Okay, but what's different about this one than the previous ones? It's not only does it have an x squared and a number, but it's got an x term. Okay, so how do we deal with ones that look like this? How do we deal with ones that have an x term in them, or 3 terms instead of 2? Okay, that's where we take what we learned last year, factoring, to help us solve, which we'll talk about next week. So for Monday, exercise 3.1, please.